All right, let's dive right in. If you're a DevOps engineer, you know the drill. We need things to be consistent, portable, and fast. In this quick explainer, we're going to do just that. We'll build your very first Docker image from the ground up and get it into the cloud. Ready? Let's go. Oh man, we have all been there, right? That one phrase, "but it works on my machine," can just grind everything to a halt. It's that classic, frustrating problem of environments not matching up. And you know what? That is the exact problem Docker was born to solve, once and for all. Okay, so before we can start building all this cool stuff, we've got to make sure our workshop is set up. Don't worry, it's pretty simple. There's really only one essential tool you're going to need to get started. And that one tool is Docker Desktop. Seriously, that's it. Think of it as your all-in-one command center. It lets you build, share, and run containers all right from your own computer. So go ahead and get that installed if you haven't already.
All right, with our setup complete, let's jump straight into the action. Honestly, the best way to get what containers are all about is to just run one. So we're going to start by grabbing a pre-built image and seeing it come to life.
So let's clear this up right now, because it's absolutely crucial. What's the difference between an image and a container? Here's the best way to think about it. A Docker image is like a recipe. It's the static, unchangeable blueprint with all the ingredients and instructions. A Docker container? That's the actual cake you bake from the recipe. It's the live, running instance of that image. Recipe, cake. Got it?
And this is where you see the real magic of Docker. With just one simple command, Docker run hello world, you're telling Docker to go find that hello world recipe on Docker Hub, pull it down, and instantly bake it into a running container. A whole isolated application is up and running in seconds. I mean, that's efficiency right there.
Okay, running someone else's container is a great way to start, for sure. But the real power, the game-changing part, is creating your own. And the heart of that whole process, the blueprint for your application, is a little something called the Docker file. So, what is this Docker file? It's literally just a text file. That's it. But don't let its simplicity fool you. This file is incredibly powerful. It's your automated instruction manual. Every single line tells Docker exactly how to assemble your image, which means you get a perfect, reproducible build every single time.
Now, to really understand how Docker files work, you got to wrap your head around the concept of layers. As Docker reads your file, each command creates a brand new, unchangeable layer. Just picture stacking transparent sheets on top of each other. Each sheet adds something new, and when you look through the whole stack, you see the final complete image. Okay, rule number one of Docker files. Every single one of them must start with a from instruction. Something like this, from node 18-alpine. This sets the foundation, the base image that everything else will be built on top of. In this case, we're starting with a nice, lightweight version of Node.js. So that from command, that just created our very first layer. And here's a huge pro tip. Always try to use a specific and small base image, like one with Alpine in the name. Why? Because it leads to smaller, more secure final images, and in a production pipeline, that is exactly what you want.
All right, next up we have the working directory command. For instance, working directory/app. All this does is set the working directory or folder inside the container for any commands that come after it. It just keeps everything nice and organized.
So this command adds another layer to our stack and sets the stage for what's next. From this point on, any commands we run, like copy or run, are going to happen inside that /app directory we just made. It's like saying, okay, Docker, do everything from now on inside this folder. So we've got our base, we've got our directory. What's missing? Our actual code, of course. That's where the copy command comes in. A simple copy ... tells Docker to copy the files from our current local directory right into the working directory we just set up inside the image. And bam, that copy command creates yet another layer, this one holding all of our precious application code. But here's where Docker gets really smart. It uses something called a build cache. If you build again and your code hasn't changed, Docker just reuses this layer instead of rebuilding it. This makes your future builds way faster. We did it. We designed the blueprint in the Docker file, and we've built the image. So what's the final step on our journey? We got to make it available to our team, or even the whole world, by publishing it to a registry like Docker Hub. It's a simple three-step dance, really. First, you build the image with Docker build. Then, you have to tag it so Docker Hub knows who you are and what version it is. That's Docker tag.
Tagging is so important for versioning. And finally, you push it up with Docker Push. Build, tag, push. That's it.
You know, building an image is one thing, but building a really good, efficient image, that's another level. So before we wrap up, let's cover a couple of pro tips that'll take you from a beginner to a true Docker pro. Okay, first, get smart with that build cache. Order your commands carefully. For example, copy your package files and install dependencies before you copy your own source code. That way, a tiny code change won't force a full reinstall of everything. Second, and this is a big one for production, use multi-stage builds. This lets you build your app in one container that has all the tools, then copy only the final compiled thing into a super tiny, clean production image. It's the secret to keeping images small and secure, which is a must for any CI/CD pipeline. And just like that, you did it. From a simple text file to a shareable, runnable application that can live in the cloud. You now have the fundamental skill to containerize pretty much anything you can think of. So, the only question left is, what are you going to build next?